A baseball team plays in a stadium that holds 68,000 spectators. With the ticket price at $11, the average attendance has been 27,000. When the price dropped to $9, the average attendance rose to 34,000. We're going to assume that the attendance is linearly related to the ticket price. And this is a really big clue right here as to what we need to do. And in general, what we want to do for this is we want to maximize the revenue. Okay, so just a quick refresher if you forget what revenue is the price of the item times the number that is sold. In this case, we're talking about the number of tickets. So that will tell us how much revenue we're taking in. Now, the price is changing with respect to the attendings. And the question gives us a big hint that that's a linear relationship. So I'm going to write down the information they gave us as ordered pairs and use that to find our linear function. So the price is changing with respect to the attendings. So the attendings is going to be our X value, or we're going to say let X be the number of tickets, which is the same as the number of people that are going to show up basically. And then the Y quantity is going to be the ticket price. So you can use any form of the linear function that you want. I'm going to use point slope form. So I'm going to use these two values here to find the slope. So I'm going to take the difference in the Y's over the difference in the X's, and we're going to find that the slope is negative 1 over 3,500. Then I'm going to plug that into my point slope form and plug in a point for my x1 and my y1. I'm using the point 27,011 for my point, but you can use either one. And then once I do a little bit of rearranging, I can get it in slope-intercept form if you'd like. So this is our price function with respect to attendings. So for this X here, that means I'm going to plug in the number of tickets sold or the number of people that attended, and then that's going to give me the price of the ticket. Okay, so now we're going to go back to coming up with an equation for the revenue. Now that we have a price function, we're going to take the price function times X, which is the number of tickets. So I have the revenue is the price, which is this function right here, times X. So when we do that, we get negative 1 over 3,500 X squared plus 18.7142X. Now, to find the critical values, I have to take the derivative and set it equal to 0. So when I take the derivative and set it equal to 0, this is what I get. So I take the derivative of our quadratic, and notice because there's this negative, our leading coefficient is negative, we know that this is going to be a concave down parabola, which again confirms that we're looking for a maximum, because if it's on an interval that's concave down, our critical value will be a maximum. So I find the derivative, that's this one right here, and I set it equal to 0. When I solve that for X, I get 32,749 and 0.85 tickets. And so this is the value of X. It's going to maximize the revenue. Now, if you want to find out what the actual cost of the ticket should be, since this is the number of tickets sold to maximize it, then I'm going to take this value of X and plug it into our price function. When I plug in the number of tickets sold or the attendings into this X, I should get the price of the ticket. And when I do that, I get 9.3571, which I'll round, because we're talking about dollars and cents here, I'll round to $9.36. So $9.36 is the cost of the ticket that is going to maximize the revenue.